So as big data ecosystems continue to evolve, Hadoop is increasingly integrating with advanced analytics and machine learning platforms. One example is RapidMiner's Redup, which allows RapidMiner Studio processes to run directly inside of Hadoop. And this means that organizations can leverage Hadoop's massive storage and distributed computing power while using RapidMiner's intuitive machine learning tools to unlock insights from their data. And this is a major step forward because it makes machine learning on big data more accessible and scalable. Additionally, Hadoop is not just about storage and processing. It can also be used as a data source for business intelligence tools like Tableau and Power BI. By connecting Hadoop to these visualization tools, companies can perform real-time data analytics, build dashboards, and generate reports from massive data sets, helping decision makers extract meaningful insights without needing to be data engineers. Now, these emerging collaborations, they show how Hadoop is becoming an essential part of the broader AI and analytics landscape. As enterprise data warehouses kind of struggle with the explosive growth of big data, one solution is to offload cold data, older data, infrequently accessed data from the data warehouse to Hadoop. And this approach, what it does is it optimizes storage costs, query performance, and overall efficiency. But before offloading, all data, both frequently and infrequently used data, is stored in the main data warehouse. And this can quickly become expensive and slow as data volume increases. By integrating Hadoop, only hot or frequently used data is going to remain in the traditional data warehouse. And cold data is going to be moved to Hadoop's distributed storage for long-term retention. This hybrid solution, it offers several benefits. Hadoop storage is significantly cheaper than traditional enterprise data warehouses, 30 times lower in cost per terabyte, meaning companies can retain more historical data without massive expense. It also improves the performance of the data warehouse by keeping only the most relevant data for active queries. And importantly, cold data in Hadoop, it remains accessible because it can still be queried using Hive or the Hadoop file system, or it can be integrated with tools like Power BI or Tableau so that you can have a deeper analysis when you need it. So this kind of data warehouse / Hadoop offloading strategy is widely used in industries that generate massive amounts of structured and unstructured data in fields like finance, healthcare, retail, telecommunications. And this allows companies to manage and analyze their data more efficiently without breaking the bank. Delta Lake, it's an open source storage layer that enhances Apache Spark and other big data workloads by bringing ACID principles. And ACID in the data world stands for being atomic, consistent, isolated, and durable. For every piece of data, we want it to adhere to the ACID principle: atomic, consistent, isolated, and durable. We have these types of transactions. I said not each piece of data, every data transaction, I meant to say, should follow the ACID principles. Traditional data lakes, they're great at storing huge amounts of structured and unstructured data. They oftentimes suffer from issues like data corruption, schema inconsistencies, things like slow query performance. Delta Lakes solve these challenges by adding a structured, reliable transaction layer to existing data lakes, such as Hadoop, the Hadoop file system, the Azure Data Lake Storage, and Amazon S3. So the diagram that you see here, it shows how Delta Lake organizes data into different layers. And this allows for better processing and analysis. First, in the raw streaming or batch data over here, the data enters what we're going to call the bronze layer. These are the ingestion tables, and the data is just stored as is, right? So that's what it looks like in the beginning. Then it moves over here to the silver layer. And in the silver layer, that's where the data is cleaned, transformed, and enriched. And then finally, it makes it out here to the other side into the gold layer. Okay, holding the most valuable process data, optimized for analytics and machine learning applications. So if we enforce the ACID principles, Delta Lake makes sure that the data remains accurate, consistent, and reliable, making it a powerful tool for organizations dealing with complex, large-scale data pipelines. An operational data store, with Hadoop, it represents the next generation of real-time and batch data processing for enterprise environments. Traditionally, businesses rely on data warehouses for structured reporting and business intelligence. But as data volume grows exponentially, integrating Hadoop, it allows for more flexible, cost-effective, and scalable solutions. So in this setup, all data, structured, semi-structured, and unstructured, is fed into the Hadoop data store. Here the data is prepared and enriched. It's cleaned, it's transformed so that you can use it in further flows. So from here, the data flows into two distinct environments. The first is the structured BI environment over here, where the enriched data is extracted, transformed, and loaded into a traditional data warehouse for dashboards and reporting. The second is an exploratory analytic environment over here, okay, where the data is stored for advanced analytics, data mining, and machine learning applications. So this hybrid approach, it leverages Hadoop's power for scalable, high-volume data storage and processing while still integrating with traditional BI tools for enterprise reporting and decision-making. It allows companies to combine real-time operational data with historical insights, enabling faster, data-driven business strategies. We also have location-based analytics, leveraging geospatial data to provide valuable insights for both organizations and consumers. It can be classified into static and dynamic approaches, depending upon whether the data remains fixed or changes over time. For organizations, a geospatial static approach, it involves analyzing geographic locations, such as picking the best site for a new store based on demographics and foot traffic. A location-based dynamic approach is going to use real-time data, such as live location feeds for targeted marketing promotions. For example, sending a discount notification to a customer when they're near a store. For consumers, a geospatial static approach over here, it includes applications like GPS navigation and data analysis, and this will help users find the best routes or track historical travel patterns. And a location-based dynamic approach is going to be more predictive and interactive. So these are for like ride-sharing apps and smart parking systems. It's going to guide you to available spots, or health social networks. It's going to track disease outbreaks based on location trends. So these location-driven insights are widely used in retail, transportation, healthcare, smart cities, and they're going to give businesses and individuals real-time, data-driven decision-making capabilities. Geospatial analytics, that's a key component of location-based analytics. It's going to let you derive insights from geographic data. And one fundamental technique in this field is called geocoding. Okay? And geocoding transforms a description of a location, such as an address, a place name, or GPS coordinates, into a precise position on the Earth's surface. And this lets businesses and analysts visualize and analyze geographic data like visual maps, postcodes, lat-long, or latitude, longitude points. So by leveraging geocoding, companies can aggregate views of large geographic areas, helping with market analysis, urban planning, disaster response, logistics optimizations. So for example, a company can map out customer locations to identify the best areas for new stores. Logistics companies are going to use geospatial analytics to optimize delivery routes based on real-time traffic conditions. So this powerful capability transforms raw location data into actionable insights, driving more informed business decisions. Here's another example. In the military and defense operations, the U.S. Transportation Command relies on geospatial analytics to monitor and manage military aircraft and logistics operations worldwide. And with this technology, U.S. Transcom, they can track detailed aircraft information, including the type of aircraft, its maintenance history, and the complete list of crew members on board. It can monitor equipment, supplies carried on the aircraft, making sure that critical resources are available where they're needed the most. And perhaps most importantly, real-time location tracking. This allows military commanders to optimize flight paths, to enhance mission planning, to improve response times for global deployments. Beyond military applications, there's also geospatial analytics capabilities used in commercial aviation, emergency responses, where real-time tracking and resource management are critical for both efficiency and safety. So this real-time location intelligence, it leverages the fact that many modern devices, cars, airplanes, ships, mobile phones, cameras, and navigation systems, they're constantly transmitting location data. And this is done using GPS, Wi-Fi, and RFID tags, right? So because all of this data is just constantly being sent out, then there's a whole branch of analytics dedicated to analyzing this. One powerful application of this is reality mining, reality mining, which converts real-time location data into actionable insights. And a great example of this is Path Intelligence. And this is a British company that developed the footpath system, which records how people move through a city, a shopping mall, or a store using their location-enabled devices. So retailers use this to analyze customer behavior, to optimize store layouts, to improve marketing strategies based on foot traffic patterns. And this type of real-time tracking and analysis is also used in smart cities. Traffic management, logistics, emergency response, even disease outbreak tracking. All of that due to the fact that everybody has a cell phone and your GPS, Wi-Fi, or RFID is constantly sending out your location. Augmented reality is another powerful application of real-time location intelligence, enhancing our perception of the real world by overlaying computer-generated visuals, sound, video, and GPS data into our surroundings. Augmented reality, it integrates location-based data with digital content, making it a valuable tool for navigation, entertainment, and business apps. So, I think about, it's not as popular, but it used to be back in the day, Pokemon Go, which uses real-world GPS locations to create an interactive gaming experience. There's Augmented Car Finder, which allows users to tag their car's location and then later track it down using augmented reality. There's also Yelp Monocle, which lets users find nearby restaurants by pointing their phones at a location and viewing business details overlaid on the screen. So beyond customer applications, augmented reality is transforming industries like retail, real estate, tourism, urban planning, giving you an interactive experience and real-time contextual information to users, making navigation and decision-making more intuitive. Analytics applications have grown rapidly with the expansion of the mobile app industry. And I'm talking about iOS, Android, Windows, Amazon. And unlike business-focused analytics tools, these applications are designed for everyday users, helping them make smarter and more efficient decisions in real time. So a great example of this is CabSense. And CabSense is an app that helps people find taxis in New York City. It uses historical GPS data and analytics to rate street corners based on cab activity, assigning scores from 0, no cab activity, to 5, high cab availability. Based off of that, users can also access interactive maps to help find the best pickup locations. Okay. Another example is Park PGH. Okay. which assists drivers in downtown Pittsburgh by providing real-time parking availability information. By analyzing traffic patterns and occupancy data, it helps consumers locate open parking spots faster, reducing congestion and frustration. And this example, or all of these examples really, it highlights how real-time analytics and location intelligence are enhancing consumer experiences, making everyday tasks like transportation and parking more convenient and efficient. So the business analytics ecosystem, it's a complex network of industries, technologies, and professionals that work together to turn raw data into actionable insights. This ecosystem includes key players such as data infrastructure providers who build and maintain storage and compute platforms, and the data warehouse industry, which organizes and manages structured data for analytical use. So the middleware industry, it plays a crucial role in connecting different software systems, enabling seamless data exchange, while data aggregated distributors focus on collecting, cleaning, and distributing data from multiple sources. Finally, analytics-focused software developers create specialized tools and applications that help businesses analyze and visualize data effectively. So beyond the core industries, there's also key stakeholders who shape the business analytics landscape, analytics industry analysts and influencers. They kind of give market insights and trends, influencing decision making in the industry. There's academic providers, there's certification agencies offering education and training that prepares professionals to leverage analytics tools effectively. Analytics user organizations are businesses that apply data analytics to improve decision making, while application developers create customized solutions either for specific industries or for general analytics use. And with that brings us to the end of this section. And throughout this, we kind of explored the power and the applications of big data and business analytics. We covered topics like Hadoop MapReduce, real-time location intelligence, geospatial analytics. We discussed how big data frameworks process vast amounts of information efficiently, and how machine learning and AI integrates with analytics to enhance decision making. We also examined real-world applications from retail and finance to transportation and healthcare, demonstrating how organizations use data-driven strategies to improve efficiency, customer experiences, and innovation. So the business analytics ecosystem ties everything together, showing how different industries, technologies, and experts collaborate to extract value from data. So as businesses continue to generate more data, the demand for scalable analytics and skilled professionals is only going to grow, making business analytics one of the most critical fields in the modern industry. And with that, my name is Dr. Lee. Hope you got some value out of this. Thank you, and I'll see you the next time.